Hey guys, Mr. Mises here, and I'm going to talk about L'Hopital's rule. L'Hopital. So this is a nice little limit rule that we can use using derivatives and to make doing some limits quite easier. So I think you'll like it. Most people do. Most people think it's pretty easy. So let's take a look at L'Hopital's rule. Thanks for joining me today. Here we go. All right. Ooh, what am I doing over there? Here. Okay, let's see. I don't know where really that move means, but we'll take a look. So let's suppose we have some limits that we can't really use algebraic methods with. So we might want to use something else. If direct substitution, like we plug in the value and that doesn't work, and we end up with indeterminate forms. Now the two indeterminate forms that we're going to look at in this class anyway, this is for AB calculus, are 0 over 0 or negative or positive negative infinity over positive, it could be negative infinity over positive infinity over positive infinity, or basically infinity over infinity. So whenever we get those two indeterminate forms, we're going to use what we call L'Hopital's rule. And L'Hopital's rule basically says this: look, if you get an indeterminate form, then what you can do is you can take the derivative of the top and the derivative of the bottom separately, and then retake that limit as your value of x approaches whatever you were doing in the first place. If that doesn't work and you still get infinity over infinity or 0 over 0, guess what? You can do it again. Take the derivative again of the top and the bottom separately. Now this is important that you remember it's the top and the bottom separately. It's not the quotient rule, right? The quotient rule is when we just do the derivative and we have a quotient. But this is, we're going to treat each function separately, the one in the numerator and one denominator. Okay, let's take a look at some examples here. So we have the limit as x approaches infinity of x over e to the x. Now if I plugged in infinity, I'd get infinity over infinity. One thing to notice here is that I'm not using an equal sign, right? This limit is not equal to infinity over infinity. It's just what I would see if I plug, as we approach. This is the indeterminate form. So what is this equal to? Well, I'm going to use L'Hopital's rule, and I'm going to take the derivative of the top, which is 1, and the derivative of the denominator, which is e to the x. And now I'll plug in infinity, and 1 over e to the infinity, 1 over infinity, which goes to 0. All right, so that's how you use L'Hopital's rule. That's really all there is to it, guys. Now, of course, there's some other complicated problems where we would use L'Hopital's rule, but really that's essentially the whole thing of it here. So let's take a look at another one. So here I'm going to plug in infinity. I'm going to get infinity over infinity. Now I could just draw that like that. Doesn't matter. I just need to know, hey, look, that's going to be an indeterminate form. So then I'm going to get limit as x approaches infinity of the derivative of the top, which is e to the x, derivative of the bottom, which is 1. And that's going to go to infinity or does not exist. Or you can just say does not exist, right? Either one of those will work. All right, let's take a look at another one. Limit as x approaches 0. Well, if I plug in that, I'm going to get 0 over e to the 0, which is 1. Hey, that's just 0. Okay, so this is just 0. So again, you should plug in values. You should plug in your value first to see if it's actually an indeterminate form. This one was not. It was 0 over 1, which was just 0. All right, how about limit as x approaches 0 from the left? Well, the limit as x approaches 0 from the left, if I plug in 0 here, I'm going to get 1. And if I plug in 0 here, I'm going to get 0. So that's going to be an infinity. However, since I'm approaching from the left, that means x values are going to be negative, right? Small little negative x values. So that's going to be a negative infinity. Or you can say this does not exist. Either one works. So not all of these have L'Hopital's rule, right? You got to plug in and figure out what's going on. Okay, let's try this one. Limit as x approaches 0. So I plug in 0 here. This is going to give me 1. That's 3 minus 3, which is going to give me 0 on top and 0 on the bottom. All right, so I can use L'Hopital's rule. So let's L'Hopital it. L'Hopital rule it. Derivative of the top, the derivative of 3 is 0. The derivative of negative 3e to the 3x is going to be negative 9e to the 3x, right? Because we got chain rule. Chain rule. It's like my Chia Pet song, only with chain rule. Chain rule. Chain rule. Green hair coming out of my head. All right, so then we get that, and now we plug in 0, and we're going to get negative 9. Boom. L'Hopital's rule. Awesome. Okay, so here's a couple of things. All right, do not use L'Hopital's rule just because a problem kind of looks like something else. You have to put direct substitution in first before you can use L'Hopital's rule. All right, so if it doesn't give you one of these or these, you cannot use L'Hopital's rule. I think I said that enough. You guys say, did I say enough? Maybe you got me on fast forward. I'm talking really, really fast, so you're gonna talk me. You want me to talk slower. All right, so slow it down. Here we go. Let's take a look at 2 more examples. Okay, so again, I said in the beginning of this video, if L'Hopital's rule doesn't work once, you can do it again, and it should work after the second time. If it doesn't work after that time, do it again, and you can do it a third time and see what happens. All right, let's take a look at another example. We put negative infinity in there. That's going to give me a positive infinity, right? Because a negative times a negative is a positive. And the negative infinity here is even, and we're going to get infinity. So we're going to get infinity over infinity. So let's use L'Hopital's rule. L'Hopital's rule. Limit as x approaches negative infinity. The derivative of the top is 2x. The derivative of the bottom is negative e to the negative x. All right, plug negative infinity here. I'm going to get negative infinity. I'm going to use a different color here. Okay, I'm going to get negative infinity. And then the bottom, I'm going to get negative infinity again. So that's perfect. Well, it's not perfect. It's not what I really want, right? It does tell me now, hey, you can use L'Hopital's rule again. So we're going to use it again. Limit as x approaches negative infinity. The derivative of the top is 2. The derivative of the bottom is positive e to the negative x. Chain rule. Don't forget the chain rule. All right. Now I'm going to get 2 over infinity, which is going to make this limit 0. Boom. All right. So multiple uses of L'Hopital's rule. Let's take a look at this one. What? What is this one? What you talking about? Okay, ln of 1, 0. Minus 1 plus 1 is 0. 0 minus 0. I'm sorry. What am I doing? 1 minus 2 plus 1 is 0. So we got 0 over 0, which we can use L'Hopital's rule. So we'll use L'Hopital's rule. Limit as x approaches 1. Derivative of ln x is 1 over x. Derivative of x is 1. Derivative of 1 is 0. Derivative of x squared is 2x. Derivative of minus 2x is minus 2. Derivative of 1 is 0. Okay. That's what we have. Go and plug in 1. Plug in 1. We get 1 minus 1. Oh, man. 0. 2 minus 2. Oh, man. 0. 0 over 0. Shoots. Shoots. What do we do? Shoots. We do it again. Limit as x approaches 1. I'm going to change this bad boy to x to the negative 1. And I'm going to get negative 1 times x to the negative 2 minus 0. Come on, man. Over 2, right? Derivative of 2x minus 2 is 2. That's the same thing as limit as x approaches 1. Negative 1 over 2x squared. Plug in 1, and I get negative 1/2. Bam! L'Hopital's rule. All right, so there you go, guys. That's L'Hopital's rule. We're doing calculus now, right? We're doing calculus. All right, so if you like this video, you like my other videos, subscribe. Please subscribe. Bam, boom, I'm out. See you later. Bye.